homework. There's homework due tonight. It's homework number 4. Which means I'm going to post homework number 5 today. I'm posting homework 5 today. It's due next week on the 28th. Okay, so today we're going over a lot of examples with the complement rule and the general addition rule. We wrote down the complement rule last time, but we're going to put it up again. For any event A, let A be an event. Then the probability of the complement of A, the probability of A is equal to 1 minus the probability of A. So in the first example, A is an event. Such that the probability of A is equal to 0.38. Find the probability of the complement of A. Use the rule. Probability of A complement is 1 minus probability of A. And then substitute that number in, put in a 0.38 for probability of A. One minus 0.38 is 0.62. So this time, the probability that it will rain tomorrow is 92%. What is the probability that it will not rain tomorrow? Okay, first we're going to take what we're given, the information that we're given, this part right here. The chance of rain is 92%. How we're going to do this is we're going to do P for probability of rain. That's equal to this from the problem we're given, 92%, which is 92 out of 100 or 0.92. And then we want to find the probability of the opposite event, which would be no rain. And use the complement rule. Maybe 1 subtract the probability that there is rain. Subtract the 0.92. And that is 0.08 or 8%. Oh, right. So there's a 92% chance of rain, 8% chance of no rain. A bag contains 100 marbles. There are 30 red, 45 yellow, and 25 green. We're going to do two parts. The first part, so what is the chance that you select one marble and it's green? So find the probability that a randomly selected marble is green. Okay, we're going to do this type of notation where I'm going to use P for probability of selecting green. And then to find that, you take the number of outcomes in this event, the number of green marbles, divide by the total number of marbles. And for green, it's right here. There's 25 of those to choose from. And I mean, you can add these together and check, but we're told that there's 100 total. And 25 out of 100 is 0.25. Part B, we're going to find the probability that you select a marble and it is not green. One way to do that is you can find the probability of the other colors and add them together. Or what we're going to do is use the complement rule. So part B. is the probability that a randomly selected marble is not green. I'm going to go start this over on the side. So it's probability of this event, selecting a marble that is not green. So I'm going to use the complement rule. I want to use 1 and then subtract the probability of the opposite event, the probability that it is green. So we're just going to substitute that number in. Take 1 and subtract 0.25. Just 0.75. For 75%. This time our space contains some letters. And I mentioned it to my class earlier that so far we've been working with spaces with just a few elements. Like this. S contains H, I, J, K, L, M, N. But I think what we will do is probably next week, we're going to talk about different ways to count, and then using counting techniques, we can look at spaces that are much bigger and then count all the possible outcomes in that space. Okay, but this one, we can just draw what's going on. So I think what we want to do is have one subset A. It contains J, K, and N. And we're going to start with the Venn diagram. So sketch out the space as with just one subset A. In the set A is J. Outside of your set, you've got H, I. J, K, we need L, M. This part finds the probability of A. You get the number of elements in A, divide by the total number of elements. There are 3 elements in that set. There are 1, 2, 3, 4, 5, 6, 7 total. 3/7. And then we're going to finish this example with finding the probability of a complement. Complement rule. The probability of a complement would be 1 minus the probability of A. And substitute that number in. It's 1 minus 3/7. Rewrite 1 as 7/7. So that you have that common denominator of 7. And you get 7 minus 3/7. All right, so this time we've got a fruit basket and we want to randomly select one of the fruit. It has 8 apples, 2 oranges, 1 banana, all right, we're looking at 3 mangoes and 5 pears. For the first part, find the probability of randomly selecting an apple. So we're going to write probability of selecting an apple. And it equals the number of apples, all the different choices for that event. And divide by the total number of outcomes. Okay, there are 8 apples. And we have to see how many fruit we have total. 5, 6, 7, 8, 9, 10, 11, plus 8 would be 19. Then for the next part, what is the probability that you randomly select a fruit that is not an apple? All right, I'm going to use the complement rule. We're looking for probability of not selecting an apple, which we're going to shorten it. Just put not an apple. Then I'm using the complement rule. You take 1, subtracts the probability of the opposite event. So probability that it is an apple. And we just found that number. It was 8 out of 19. So we've got a 1 minus 8 over 19. Get the common denominator. So 19 over 19 minus 8 over 19. Would be 11 over 19. Okay, so I'm introducing another rule, and then we're just going to practice this rule for the rest of class. It's called the general addition rule. So this part, the general addition rule, works for any sets, any two sets, A and B. If you need to find the probability of A union B, this is equal to the probability of A, add the probability of B, and you need to subtract the probability of A intersect B. So I'm going to sketch out what happens, but then I think an example will help explain why you need to do this part at the end, minus this probability. So this is the sort of the idea. We've got a space. And then we have two subsets, A and B. And we're trying to find the probability of both sets together, A union B. It's all of this in both circles. So we're going to use shading to represent probability. When you find the probability of A, you count how many numbers or elements are in A, and then divide by the total. And then add the probability of B, so you count how many outcomes or elements are in B, and then divide by the total. So if you add those together, you've counted this intersection twice. So remove one copy like this. Remove one of those values where you have the probability of A intersect B. Okay, so for our example, the space space contains 0 through 8. A contains 2, 4, 6, and 7. E contains 5, 6, and 7. Let's draw a Venn diagram. First, I would look for common outcomes, like they both share 6 and 7. And then over in the set B, you have 5. In set A, there's 2 and 4. Outside of your set, you need 0, 1. There's 2. Let's put 3 and 4, 5, 6, 7, and we'll have 8. Find the set A intersect B. So it's outcomes in A and B. Oh yeah, 6 and 7. Nice, thank you. And then find the probability of A intersect B. So this one doesn't have a formula. You use the definition. So you go with probability of the set A intersect B. It's the number of outcomes in A intersect B. Over the total. Yep, thank you again. And yeah, those 2 outcomes in the set. And then we've got 9 total, but I'm going to double check just to be safe. I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, thank you for that answer. Then find the probability of A union B. This one I will use a formula. I want to use the general addition rule. Probability A union B equal to the probability of A. Add the probability of B. Subtract probability of A intersect B. For this one, you find the number of outcomes in A, put it over the total, which there's 1, 2, 3, 4 in that set, 4 outcomes in that set, and there were 9 total. Probability of B, you find how many outcomes are in B, which is 1, 2, 3 outcomes, put it over the total, left, right. I just got this number. It's subtract 2/9. So since we've got a common denominator of 9, this is 4 plus 3 minus 2 over 5/9. let's do. Space S contains 1, 2, 3, 4, 5, 6, 7. A contains 1 and 4. B contains 5. And then first thing to do is draw a Venn diagram. And I'm going to have the sets overlap, but they have no outcomes in common. So that means they are disjoint. Over in set B is 5. Over at set A is 1 and 4. And then from the rest of the space, we've got 2, 3, 6, and 7. Okay. Find A intersect B. So it's the set of elements in A and B. And you can say it's, yep, it is the empty set. Awesome. Or you can put the symbol, which would be a 0 with a slash, but empty set is easier, I think. Since we're mostly typing our answers this semester. Okay, find the probability of that set. So we're going to use the definition. Probability of a set is the number of outcomes in that set over the total. Okay, number of outcomes in A intersect B. But A intersect B doesn't have any outcomes. So we've got 0 divided by 7 total. 1, 2, 3, 4, 5, 6, 7. Yeah, but still, it's going to be 0. 0 divided by any number is 0. So just a note, in this class, this symbol is a set, the empty set. This symbol is a number. That's the number 0. All right, find the probability of A union B. This time, I am going to use a rule. It's the general addition rule. You take this probability. If it's a union, then you can write this as the probability of A add the probability of B. Then you have to subtract the probability of A intersect B. This first number, look at your set A. It has 2 elements. So we're going to take 2, put it over the total 7. Probability of B, find how many elements there are in B, which is just 1. Minus probability A intersect B. We already looked at how many elements there are in A intersect B. There's 0. And you can put it over the total, but it's just a minus 0. Okay, so that's going to be 3/7. And by the way, there is a rule for disjoint sets where you know that if your sets are disjoint, this number is always going to be 0. But that rule can confuse people sometimes, so I'm going to keep the general addition rule and just use this one every time, just to be clear that because it works for any sets. So let's go on to a new space. I'm going to back up. I'm going to introduce the space. So this is the space that represents flipping a coin 2 times. This is the space that contains the outcome of 2 heads in a row, heads, heads. there's the chance you get heads and tails. Or maybe a different outcome of tails than heads. Or you get two tails in a row. Tails, tails. Event A is getting heads, heads, or heads, tails. Event B is going to contain heads, tails, tails, heads, tails, tails. Okay. And then first thing to do, draw a Venn diagram. Let's do the space. That's subsets A. And their shared outcomes are in the middle, where they both share HT. In the set A, there's also HH. Over in set B is TH and TT. And then just make sure you have all the elements from the space. There's the HH, HT, THTT. So it's the Venn diagram. Find the set A intersect B. A intersect B is the set of elements in both A and B, which is that element right there, HT. Next, get that probability of A intersect B. For the probability of A intersect B, we're using the definition. You find the number of outcomes in A intersect B, divide by the total. And then if you would like to take a guess, I bet you'll get it. Okay, well, we'll check out our set A intersect B. It has one outcome written as a pair. And then the full space has 4 outcomes. It's 1, 2, 3, 4. Find the probability of A union B. So I'm going to use the general addition rule. Take this probability is equal to, we're going to go down here, probability of A, and then add the probability of B. You have to subtract probability A intersect B. Okay, this number first. Probability of A is the number of outcomes in A over the total, which there's 2 outcomes in that set, and 4 total. Probability of B, you check how many elements there are in B, which is 1, 2, 3 elements, and divide by 4. Subtract probability A intersect B. So count the number of elements in this set, which is just 1, or we did it over here, this 1 out of 4. Okay, so you keep the common denominator of 4. And in the numerator, you go 2 plus 3, which is 5, and subtract 1. So I got 4 out of 4. And 4 over 4 is 1. Or 100%, either way. Let's see what time. Let's try one more example. So our last space for today is going to include A, B, C, D, E, and F. A contains B and C. And then set B contains A, E, and F. Let's draw the Venn diagram. Okay, let's check for common elements between A and B. There's no common elements, so this part's going to stay empty. In the set A, we're going to put B and C. over in set B, we have A, E, and F. Then there's A, B, C, you need D. Then E and F are all of your elements. Find the set A intersect B. So it's the set with elements in A and B. And there are no elements in both sets, so it's empty. And let's get the probability of that set. So for this one, there's no rule. What we're using is the definition. The probability of a set is the number of outcomes in the set divided by the total. So the probability intersect B, get the number of outcomes in A intersect B. And divide by the total number in S. The number of outcomes in A intersect B is 0. There's no outcomes in here. And even though there's going to be 1, 2, 3, 4, 5, 6 outcomes in the set, 0 over 6 is still 0. Last part, find the probability of A union B. Okay, this time we are going to use a rule. I could use the definition, but I want to practice the general addition rule. So we go here. For the union of sets, I can write this as probability of A add the probability of B and subtract the probability of the intersection. A intersect B. Start here. Probability of A. You look at how many elements there are in A, which is these two, divide by the total. 6. Probability of B. For the set B, there's 3 outcomes. Put that over the total. Then probability of this set, there are 0 outcomes in the intersection. We already did this part. We're subtracting 0. So what I've got is 5 over 6. For that probability. Okay, cool. So next time, we'll keep practicing this rule. The probability of A union B is always equal to the probability of A plus the probability of B. Subtract probability A intersect B. And then I'm pretty sure after that we can start talking about different ways to count, and then we'll use counting techniques to find more probabilities. Okay, that's it for today. I will put your homework up tonight. Please try it over the weekend, and then have a good weekend.